Hey everyone, this is your week 12 wrap-up video. All right. So this week we looked at carboxylic acids and their derivatives. And so we looked at carboxylic acids, esters, amines, and amides or amides. Okay, so carboxylic acid, it has this carbonyl group. In fact, it has a carbonyl group, and there's a hydroxyl, an OH attached to that to the carbon of the carbonyl group. So these are all examples of carboxylic acids. So it can look like this, where the other carbons, H. Don't confuse this with the aldehyde. This does look like an aldehyde, but if there's an OH on the other side, then it's a carboxylic acid. It can be attached to another carbon. It could be attached to, aromatic ring or both. And often this functional group is shown as COOH. Okay, so for naming, again, we're not going to get too complicated. So um, if you know the ending, so the suffix, and you know those prefixes of like methyl, ethyl, propyl, butyl, pentyl, you should be fine with naming, okay? So for carboxylic acids, we use the oic acid ending, okay? So this is a good example here. Here we have 1, 2, 3 carbons with that carboxylic acid functional group. So that would normally be propane, but we change the end to propionic acid. And I guess that's kind of um, not exactly using this oic acid suffix, but again, I won't give this specific one to a test, but uh, you should be able to pick them out of a multiple choice question. Okay, and then these are common names. You don't need to know those, but again, formic acid is a pretty common name, and acetic acid is another common name. If we look at this top one, this is 1, 2, 3, 4. So that's 4 carbons. That would be butane. It has this carboxylic acid group. So we change the N to oic acid, butanoic acid. But then if we count over, again, the carboxylic acid functional group is going to be at carbon 1, carbon 2, carbon 3. So at carbon 3, we have this chlorine. So this becomes 3-chlorobutanoic acid. Okay, another question you guys had was about aldehydes. Now remember, aldehydes have a carbonyl group like carboxylic acids, okay? But they don't have that hydroxy group. So one of the reactions to make carboxylic acids is to take that aldehyde and oxidize it. Notice that we started off with 2 bonds to oxygen with this carbon here. We undergo oxidation. Now this carbon has still those 2 bonds to oxygen, but also this third bond. And one of our definitions of oxidation is more bonds to oxygen, okay? And we can do kind of similar things shown like this. Again, CHO, remember, is aldehyde functional group. So this is ethanol, and we can oxidize it to ethanoic acid. Now we went from this aldehyde functional group to this carboxylic acid functional group. And again, what helps me is thinking about 2 bonds to oxygen. And once we oxidize, now we have 3 bonds to oxygen. All right, so the next functional group was an ester. And esters are formed from carboxylic acid and alcohol. And so the ester functional group, again, you have that carbonyl. This time the carbon of the carbonyl is attached to an oxygen, and that oxygen is attached to a carbon, right? It's not an OH group, it's an OR group, meaning there's carbons over here. So it could be something like this. Again, here's your carbonyl. It's attached to an oxygen, and that oxygen is attached to some carbon group. They're formed from a carboxylic acid and an alcohol. So the carbonyl portion comes from the carboxylic acid. The OR portion comes from the alcohol. So one of your questions you guys had you had questions about was this one. So classify the following molecule. So we see the CO double bond, so that's our carbonyl. We see a hydrogen here, so you might think aldehyde, but you have to look over here and see that it's bonded to oxygen, but it's not an OH, so it's not a carboxylic acid, it's a OR, right? These are more carbons. So this is an ester, okay? Like we just saw over here, this is an example of this ester, okay? So you would classify it as an ester. Naming esters, again, I do not plan to uh, make, you know, make this super complicated because naming can get really involved when we start getting into more of these functional groups. Um, and so for the esters, you usually name the alkyl part of the alcohol, right? The OR group, and the carboxylate anion name. I am telling you guys this to expose you to this material. I do not plan on testing you on this. Okay. So again, if we look at that, this is the OR from the alcohol. So this is a methyl group. This is a 2 carbon group. So that's a ethyl group, right? So you have methyl ethanoate. Okay. This is phenyl propanoate. Okay, and you can see the phenyl. This is a phenyl group, and the propanoate comes from this being 3 carbon group here. Okay, that is just more for FYI. Okay. So you guys had questions about the hydrolysis of esters, and this is a typical reaction that happens, and we're gonna look mainly at the acid hydrolysis of esters. Because something interesting happens here. Just like we can bring a carboxylic acid and an alcohol together to make an ester, like we said previously, we can also hydrolyze, meaning using water to break an ester and get back the carboxylic acid and the alcohol. So here we have our ester. We're adding water, and this H plus indicates acidic conditions. And so it's going to break the ester bond here, and we get back carboxylic acid and the alcohol. Here's an example. This is isopropyl acetate. Again, this is written in a more condensed form. It's not showing you the bonds, but if we use water in acidic conditions, we can get back the carboxylic acid of acetic acid and the isopropyl alcohol. So again, just carboxylic acid and alcohol make ester. And we can also hydrolyze, meaning break an ester using water to get back a carboxylic acid and an alcohol. Okay, and then so another functional group we looked at was the amines. And so these are all considered amines, and it's when you have this nitrogen and it has, it's just bonded to other things. As long as the nitrogen is not bound to a carbon of a carbonyl, you can consider it an amine. So this is 1, 2, 3, 4 carbons. You have a amine group on carbon 2. This is 2-aminobutane. This is a common name, aniline. This is dimethylamine. So telling you there's 2 methyl groups attached to your nitrogen. Oops. So you again know if the word's amine, that's telling us that there's a nitrogen present in our molecule. What's the structure of dimethylamine? So we just saw that on the previous slide. And so again, it would be, we see the word amine, we know there's a nitrogen, we see methyl, we know it's a 1 carbon group, but di tells us there's 2 of them. Okay, so here we can see 1 methyl, 1 nitrogen. No. On our second choice here, we can see this two carbon group, and there's three of them. So that would be a tri, and that would be an ethyl. So no. Um, we can see this OH functional group. So that kind of throws that one off. But here we have a nitrogen, a hydrogen, and a methyl group here, and a methyl group here. So those are two methyl groups attached to a nitrogen. Remember, nitrogen prefers to make three bonds, so it's bonding this methyl group, and this hydrogen. So this would have been the right choice here, that last one. Some physical properties of amines that you should know. Well, this is a question you had regarding the physical properties of amines was about the solubility. So this question asks which compound is more soluble in water. We have this propane, CH3, CH2, CH3, okay, or this dimethylamine, CH3, NH, CH3. Remember, with something like propane, it only has carbons and hydrogens. These are all non-polar bonds. There's no hydrogen bonding going on here, okay? With something like dimethylamine, you have a hydrogen bound to a nitrogen. So that's a possibility for some hydrogen bonding going on. And so that would make it more soluble in water. So the correct choice here would be that dimethylamine. Okay, and the last functional group I believe that we looked at this week was amides or amides, okay? And these are different from amines, but they both contain nitrogen. Amides are going to be formed from carboxylic acid and amine, okay? So again, you have a carboxylic acid portion. It will combine with an amine and form an amide. Notice what the functional group is here. It is, we have that carbonyl again, so C double bond to oxygen. And the carbon of the carbonyl is bonded to a nitrogen. That makes an amide functional group. Okay. And so, again, just like with our esters, they can be hydrolyzed, meaning water is used to break them apart back into the carboxylic acid and amine that made them. Okay, so that's a similar reaction, right? Carboxylic acid and amine are used to form an amide, but we can also use water to break it back to the carboxylic acid and to the amine. Okay. Oh, and that's it. All right, you guys, I hope you have a restful break.